Hello and welcome to a new segment of Mathematics on Matrices. Today we shall be starting this segment by the basic definition of a matrix. After that we are going to discuss orders of a matrix. Later we shall evaluate the types of matrices, and finally we shall conclude the first segment on matrices by dealing with some numerical problems that would be based on the types of matrices that we are going to discuss in the coming session. Now, starting with the basic definition of a matrix can be defined as an array of real numbers arranged rows and columns. Now, we are going to consider an example of a matrix in which the horizontal lines are said to be rows and the vertical lines are said to be as columns. That means in this given matrix, the rows are 3 and can be written as row 1 consisting of elements 2, minus 3 and 7. The row 2 has elements 1, 7 and 70. Row 3 has elements 10, 3 and 21. Similarly, column 1 consists of 2, 1 and 10. Column 2 consists of elements minus 3, 7 and 3. And column 3 consists of 7, 70 and 21. Thus, in this given matrix, we have 3 rows and 3 columns. Therefore, it has 9 elements in total, and the elements inside these two vertical brackets are known as the elements of a matrix. Next, we come to the order of a matrix. For example, in the given matrix, we have 2 rows and 2 columns. Thus, the order of the given matrix can be written as 2 by 2, where the first component refers to number of rows in the given matrix and the second component as number of columns in the given matrix. Thus, in order to evaluate the order of a matrix, we need to find out the number of rows and number of columns in a matrix. Next, we are going to discuss the types of matrices based on their orders and values of the elements of the matrices. The first type of matrix to be discussed are rectangular matrices, in which the order of the matrix is m into n, where m represent the number of rows and n represent the number of columns. And number of rows and number of columns are not equal. That means m is not equal to n. This type of matrix is known as a rectangular matrix. Now we are going to consider an example of a rectangular matrix which consists of 2 rows and 3 columns. Thus, the number of rows and number of columns are not equal. Therefore, this represents a rectangular matrix. Thus, any matrix with unequal number of rows and unequal number of columns represent a rectangular matrix. Next, we come across another type of matrix which is known as a row matrix, in which the number of rows is only restricted to 1. For example, in the given matrix, we have only 1 row and 4 columns. That means this represents a row matrix. Another type of matrix is a column matrix, in which we have only 1 column and whose example can be given as a matrix in which we have only 1 column consisting of elements 2, 1 and 3, and 3 rows which has first element of first row as 2, the second row has one element as 1, and the third row has its element as 3. Thus, in the given matrix, we have only 1 column, and therefore this matrix represents a column matrix. Next type of matrix to be discussed is a square matrix, in which the number of rows and number of columns are equal. Therefore, it represents a square matrix. Now we are going to consider an example of a square matrix which consists of 2 rows and 2 columns. Thus, the number of rows and number of columns are equal. Therefore, this represents a square matrix. Another type of a matrix is a diagonal matrix, in which the number of rows and number of columns of the matrix are equal. That means it is a square matrix. and whose all elements are 0 except of that of the leading diagonal. Now considering the given matrix example, we can see that the all elements of the given matrix are equal to 0 except for that of the leading diagonal whose elements are 2, 3 and 5. Thus, any matrix whose all elements are 0 except for that of the leading diagonal are said to be a diagonal matrix. Another type of matrix is a scalar matrix, which is a type of diagonal matrix and has all the elements of the leading diagonal equal. For example, in the given matrix, we have all the elements equal to 0 except for that of the leading diagonal whose all elements have the value of 2. Thus, this matrix represents a scalar matrix. Next type of matrix to be discussed is a unit matrix, which is also known as an identity matrix. An identity matrix is a square matrix whose all elements are 0 except for that of the leading diagonal whose all elements are equal to 1 or unity. For example, in the given matrix, we have the diagonal elements as 1 and all other elements equal to 0. Thus, this represents an identity or an unit matrix. Next, we are going to discuss comparable matrices, in which if two matrices, let's say A and B, are comparable, then they must have same order. That means if we say that A is comparable to B, then the order of A must be equal to the order of B. Or we can say that the number of rows and the number of columns in A must be equal to the number of rows and the number of columns respectively in B. Another type of matrix are equal matrices, in which if two matrices have same order and each element of one is equal to the corresponding of element of the other, then the two matrices are said to be equal. For example, now let's say we have two matrices A and B whose elements are as shown. Now here the order of A is 3 by 3 and the order of B is 3 by 3 again. Now here the two matrices are comparable since they have same order, but since the element of the second row and second column of A and B are unequal, and similarly the element of the third row and third column of A and the element of the third row and third column of B are unequal again. Therefore, these two matrices A and B are said to be unequal or not equal matrices. Next type of matrix is a null matrix, which is also known as a zero matrix and whose all elements equal to 0 as shown in the given matrix. Here the order of the given null matrix is 2 since it consists of 2 rows and 2 columns. Next we are going to discuss a numerical problem that would be based on the equality of matrices. Here we have a problem in which we are supposed to find the values of x and y such that the two given matrices, that is A and B here, are equal. As we have discussed in the previous section, that for two matrices to be equal, the order and the corresponding elements of the two matrices must be equal. So as we can see that the order of A and B is equal to 2, thus these two are comparable, and thus we can equate the values of x and y by keeping the corresponding values of A and B equal to each other. So now first, keeping the value of first element of A, which is equal to 2x plus 1 equal to x plus 3. Now equating these equation, let's say label it as 1, we can get the value of x by putting the values of x onto the one side and the constant terms onto the other. This gives us the value of x equal to 2. Similarly, the second column first element, which is y plus 2, can be put equal to the corresponding element of b, which is equal to 3y. Now equating this equation number 2 by keeping the y terms onto the one side, we can get the value of y as 1. Now putting the values of x equal to 2 and y equal to 1 in matrices A and B, we can have the values of matrices A and B equal to each other. Thus, for A and B to be equal, the value of x must be 2 and the value of y must be equal to 1. With this, we conclude the first segment on matrices.